All right, welcome back, folks. So that's all set up in the classroom now, so hopefully anyone who's joining in late will see the correct link. Today is going to be pretty short, I think. The topic that we're dealing with doesn't take too long, so let's get right into it. Welcome to the 14th day of remote learning. Today's joke is, what kind of dog makes the best magician? A Labracadabrador. Happy Friday. Factor that like button to show your support. Just a heads up that on Monday we'll have a short form as part of the assignment that is a place for you to give some feedback on the live stream lessons. So consider what you'd like to see change and what you want to keep the same. And if you know people in the class who aren't participating in the live stream, please let them know about that so that they can let me know how to make it easier for them to participate. So as I said, today's lesson should be pretty short. We're going to take the compound angle formulas from Monday, and we're going to use those to create some double angle formulas. And as always, a reminder, if you're the second or last person on the stream at the end, if you can just wait until everyone's had their questions answered before you shut it down, that would be very much appreciated. Okay, so jumping right in, double angle formulas, May 8th, 2020. So as a beginning, let's recall from Monday that we have sine A plus B equals sine A cos B plus cos A sine B. And of course, we might have written it the other way around. We might have written sine B cos A, same difference. For cosine, we have cos A plus B equals cos A cos B minus sine A sine B. And for tangent, it's a little bit of a trickier one, but not too bad. We have tangent of A plus B equals tan A plus tan B all over 1 minus tan A times tan B. So those are our compound angle formulas. We all have similar ones where we change the addition to a subtraction, and that changes all the signs over here. But that's basically our starting point. So today we're going to be looking at double angle formulas. And what we mean by that is exactly what you'd expect. What's the formula for sine of 2x in terms of ratios for x? Well, turns out this is really easy once we have the compound angle formulas, because sine of 2x is just sine of x plus x. And that means we're going to get sine x cos x plus sine x. Ooh, I'm going to run out of space here. Let me do that a little better. Equals sine x cos x plus sine x cos x. Or we might write these in the opposite order, doesn't matter. Well, these two terms are both the same thing, so that is 2 sine x cosine x. And that is our double angle formula. Oh, looks like it blurred a bit there. Let's see if I can sharpen it up. Okay. So, a bit of glare. There we go. Zoom. Zoom. Okay. I think we're good now. One more focus, maybe. All right. So double angle formula for sine 2x is just 2 sine x cosine x. And we need to be careful because some people think it should just be 2 sine x. That is not true. So sine 2x is not equal to, 2 sine x. And if you want a proof that this is not true, you can just consider the angle 90 degrees. So 2 times 90 degrees is 180 degrees. Sine of 180 is 0. But sine of 90 degrees is 1. 2 times 1 is 2. So if this were true, then 0 would equal 2. Clearly that's not true. So we can determine that this is not going to be a true identity. And in fact, this one here is the correct one. All right, questions so far, just type them into the chat. But that is our first double angle formula. We're going to get the double angle formulas for cosine and for tan in much the same way. So if we want cosine of 2x, well, that's cosine of x plus x. And that is cos x times cos x minus sine x times sine x. And the tradition is that we write that as cos squared x, like this, minus sine squared x. And this is a bit of a weird way to do it. To me, it would make a lot more sense to go cos x all squared, but that is not the accepted simplest form in the mathematical community. Cos squared x is the accepted simplest form, so we're going to use it, and that's what you'll see other people using. So cos squared x just means cos of x all squared. So that gives us our double angle formula for cosine. So we can write it out. Cosine 2x equals cos squared x minus sine squared x. Oh, getting off the page there. And then our final one is for tangent. So we have tan 2x, and same process, equals tan x plus x. And then if we use our compound angle formula from up here, but instead of a plus b, we have x plus x. So everywhere there's either an a or a b, we'll get an x. So we'll have tan x plus tan x over 1 minus tan x times tan x. And in simplest form, that is tan squared x. Oh, no, sorry, that is 2 tan x. 2 tan x all over 1 minus tan squared x. There we go. So deriving the formulas, as you can see, very straightforward. We're going to look at some of the use of these formulas. But first, I'm going to give you a little while. If you can just type in the chat any questions that you have, or if you don't have any questions, just type a 1 in the chat so that I know that you've heard this and that you're good to move on. Thanks, Daniela. Thank you, Caitlin. So it looks like we're getting pretty different levels of lag from person to person right now, which is interesting. So I'll try to keep that in mind. Thank you, Ramaisa. All right. So I think there's one more person in the chat. If you have a question, feel free to keep writing it, and I'll take it when I see it in there. Don't worry that I'm continuing to talk about some other stuff. I will make sure to come back and answer anything that you put in to the chat. So if you head over to the Google Classroom, there were a few attachments. We're looking at the one that's called Double Angle Formulas Lesson. And we're just going to try out a few of the questions that are in there. and get a sense of how these double angle formulas typically get used. So if you scooch over there, the first page, the top part is just showing how to get the sine 2 theta angle formula, which is what we have here. So if you want to do that, you have sine 2 theta equals 2 times sine theta cos theta. And then question A is asking us to use a double angle formula to rewrite sine 4x. So I'll get that moved so that you can see it. There we go. So we have sine 4x, and we'd like to rewrite this using a double angle formula. Well, sine 4x, 2x. And so now we can apply the double angle formula for sine, and we will get 2 sine of whatever angle is doubled. In this case, that's 2x times cosine of whatever angle was doubled, which in this case is again 2x. We could stop there, but we'd like to simplify it out as much as possible. So, and I'm actually going to do this at the start of the line here to make sure I have enough space. So that is 2 sine 2x. Well, sine 2x, we have a formula for. It's 2 sine x cos x. That is the formula we just developed. And cos 2x, we also have a formula for, which is cos squared x minus sine squared x. So now we've taken sine 4x and we've transformed it into something that is just in terms of sine x and cos x. And so from here we can finish the simplification. 2 times 2 is 4. 4 sine x cos x times cos squared x is sine x cos cubed x, because we had 2 and this is our third one. And then 4 sine x cos x times negative sine x using distributivity is negative 4 sine cubed x. Again, we've got 2 of them here and 1 of them here. And then cos x. So now we have a quadruple angle formula to go along with our double angle formula. So again, if you have questions, feel free to put them in the chat. And if you don't have any questions, if you can just type 1, and I'll give you a few moments to do that before we move on to the next thing. Thank you, Ramesa. Thank you, Caitlin. Thank you, Daniela. All right. So we'll keep on moving here. We have, for B, 2 sine cos pi by 8. And what we're asked to do here is to simplify and evaluate this expression. So we might try thinking about, okay, what's sine pi by 8? How can I evaluate that? What's cosine pi by 8? How can I evaluate that? And it turns out these are tricky. You know, pi by 3, pi by 6, pi by 4, those ones are all easy to do. Pi by 12 and multiples of pi by 12, we can do as well by doing differences. But pi by 8, it's really hard to find a nice compound angle way to evaluate cosine of pi by 8 or sine of pi by 8. But if we're observant, we might notice, hey, wait a minute, this is the double angle formula. It's 2 times sine x cosine x. In this case, x is pi by 8. But that is exactly our sine formula. Sine of 2x equals 2 sine x cos x. So if we have 2 sine x cos x, that's going to be sine 2x, or in this case, sine 2 times pi by 8. And 2 times pi by 8 is just pi by 4. Well, pi by 4 is the radian equivalent of 45 degrees, and we know the sine of 45 degrees is root 2 over 2, or 1 over root 2, depending on what your teacher's opinion is of radicals in the denominator. Oh, and you can't see. Oh, yeah, there we go. Okay. So by noticing that this is the right side of the double angle formula, we can work backwards through the double angle formula, and that makes it very easy to evaluate this expression. So again, I'll give you a few seconds to put in any comments. One, if you're happy with what's going on and ready to move on, and we'll take a look at a couple of questions for cosine. Thank you. All right. So Daniela and Ramisa, thank you for the ones. Caitlin, let me know how you're doing. Okay, we've got a 1 there as well. All right. So here we go. We're going to move on to the cosine, and we're asked to take cosine 1/2 x and use a double angle formula to rewrite this. So the first thing we need to do is figure out what angle got doubled. So 2 times what is equal to 1/2? Well, anytime you get one of these and you're not sure, you can just do 1/2 divided by 2, which is 2 over 1. And we know from our fraction math, we're going to flip and multiply. So, oops, sorry, we'll get 1/2 times 1/2, which is 1/4. So 2 times 1/4 x is equal to 1/2 x. And now we can apply the cosine double angle formula. Cosine squared of 1/4 x minus sine squared of 1/4 x. And you might be thinking, okay, but 1/4 x doesn't help me any more than 1/2 x. Right now, that's true. There may be situations, and these arise a lot in calculus, where you want to transform something in terms of one fraction of an angle into something in terms of another fraction of an angle. For example, if we found out that x was equal to 4 times theta for some angle theta, then having 1/4 x would be very handy because it would simplify out to theta. So there's some situations where that becomes useful. All right, and I'm going to move through and do the second one. Feel free to type in any questions that you have as we go. I will keep trying to check the chat and see what's up there. So the next one is asking us to simplify and evaluate. And so we have cos squared 3 theta over 2 minus sine squared of 3 theta over 2. And so here we can recognize that this is the double angle formula for cosine, cos squared of x minus sine squared of x. And so we're going to have cos of 2x, x in this case being 3 theta over 2. And 2 and 2 cancel out, and we get cosine of 3 theta. And it's asking us to evaluate, but unless we know the value of theta, we can't get anything better than this. So we've simplified it. There's no way for us to evaluate it without more information about theta. Okay, so I'll pause there. And again, chance for asking questions, but if you're happy with it, just put a 1 in the chat. Thank you, all 3 of you. Okay, so we'll keep moving. Another piece of paper here. go. All right, and so we'll just finish off with a couple of tangent questions. The first one here is to use the double angle formula to rewrite tan 6x. So just a reminder, the tan double angle formula is 2 tan x over 1 minus tan squared x. We already have that on the other page, but it's going to be necessary for what we're about to do. So A, we're given tan 6x. And can you rewrite this using the double angle formula? So instead of me doing this one, I'm going to give you a bit of time to try it yourself. Once you have an answer, you can just type it into the chat. We see that people have had enough time to do it, and then we'll move on from there. So once you have an answer to how do we write tan 6x using a double angle formula, go ahead and just type it into the chat. You may need to use brackets to show how the numerator of the fraction or denominator. Yeah, that looks great, Caitlin. Danielle and Rumaisa, how are the two of you doing with it? Looks good, Rumaisa? Great, thanks, Danielle. Okay, and then we'll take a look at the last question, which is to simplify and evaluate the following expression. So we have 2 tan pi by 6 over 1 minus tan squared pi by 6. So as you give that one a try, I'm just going to write out a solution for this one in case someone watches the video later and they aren't able to get it. But again, as you go through, you can finish that one up. And if you can write both your simplified answer and then the evaluated value in the chat, that would be great. So again, that's both the simplification of this and then the evaluated value in the chat. Thanks. Thanks, Ramisa. Cool. So Ramisa, it looks like you've correctly applied the formula. Do be careful though with the calculation. You might want to just put it through your calculator and see what tan pi by 3 is. You're super close. And also, I'm not talking about the exponent. There is a root 3 in there, but it's not 1 over root 3. Again, very close. So it's true that the root 3 is in the numerator, Ramisa, but it's not divided by 2. So if we were talking about cosine of 30 degrees, that would be root 3 over 2. But tan of pi by 3 is in fact just root 3. Yeah, Daniela, that looks correct. All right. So that actually wraps it up for today. Yeah, there you go, Ramisa, you got it. So if you follow the link to set 21 from the Google Classroom, there's a variety of questions for you to try there. You don't need to do all of them. So I listed in the Google Classroom itself the ones I'd like you to do. You are, of course, welcome to do other ones if you'd like some extra practice. But if you can hand in the ones that are listed in the Google Classroom, and I'll take a look at those for you. If you hand in more, I'll definitely take a look at all of them. But I think that those ones give you a good balance. So I'll stick around again for about a minute or so. If you have any questions, if you don't have any questions, if you can just put a 2 in the chat. And then once we know that we're done the questions, if you don't mind waiting until then to end the stream, that would be great. So again, put a 2 in the chat if you don't have any questions. And once we see that we've answered all the questions or that there aren't any, we'll end the stream. Good question from Misa. No, you don't need to submit the note. We've done pretty much everything. Thank you, Daniela. Good to know. Caitlin, how about you? Do you have any questions? Cool. All right. Thank you very much, folks. That's at the end of our stream for today. We'll see you again on Monday.